Okay, bring down the 1. That's why I drew the arrow. Your book has a diagram of this with many arrows, which gives me a headache. Bring down the 1, okay? 2 times 1 is 2. Then you add these, get 4. Multiply the 2 by the 4, get 8. Add them, get 2. Multiply the 2 by the 2, get 4. Add them, get -5.
We do know.
Yeah. It's a lot of multiplication, but it takes up less space. And if you're good with your times tables, it's faster. If you're not,
But why is it written
it's
so
just as
oddly?
bad. Pardon?
Why is it written so odd?
Wait.
Didn't invent the notation, darling. Can't answer that one. Amanda.
Oh. Okay, so it always drops down a degree. It doesn't matter if it comes out negative.
The only reason it always drops down a degree is because you're always only dividing by a first degree. Okay? So that's why it is. So that's only true of synthetic division. Don't take these rules back to polynomial long division. Okay? Polynomial long division is different. We'll go over that a little bit more with rational functions. But Brian, yes, you have a question?
Can you do that again? Just like show me what you did on the table real quick.
Okay. Drop the 1. 2 times 1 is 2.
Alright.
Add the column. Get 4. Multiply by the 2. Get 8. Add the column. Get +2. 2 times 2 is 4. Add the column. Get -5.
Okay.
And then everything starts a degree lower than what you started with, and the last number is your remainder. Artur.
We have to know the square type.
Yes.
Does it like it the other way too?
I did 2 when I was your age, actually. I really like the other way, but there's a method we're going to use where I've finally been convinced this is a lot better. It's a lot faster. I'm on maybe not this test, either this test or the one after it. You're going to have single problems that, depending on how lucky you are, and I'll explain that later, you'll have to do this 2 to 5 times in a hurry on a test. So I'm going to do it one more time, and I'm going to do it a little faster this time to show you what I want. But now we're going to divide the same thing, new example. We're going to divide the exact same one by, use the same one in the book so I can check my answer, x plus 3 instead.
Well, how about we do it on our own?
Hold on, I'm going to show you this before I give you one on your own. Okay, so here's what I'm looking for. It's divide the same thing, so it's going to be 1, 2, -6, -9. Because this is x plus 3, I put a -3 out here.
Why?
Okay? That's the rule. You always switch the sign. I can teach you why.
So like if it's
Okay, up. Ready? And drop the 1. -3 times 1, -3. Add them, -1. -3 times -1, +3. Add them, -3. Multiply them, 9, 0. That's my remainder. My answer is x squared minus x minus 3, remainder 0.
I didn't say it goes so fast.
That's
You did to show it.
I was doing that to show you how
Now,
fast it can be
what
if
happens-
you're quick. Now we'll do a couple more slow ones.
What happened to the cube? How can we know it's x squared minus x? How do we know the
The short answer to that, let me give you a short answer to that, okay? If you look at this fraction, everybody take a look at this. Amanda, too. I think this will help what you were asking with. Whoops. Maybe a short answer. Okay. Amanda, Phil, and anyone else who wants to understand a little more deeply, Artur. If you have something that begins with x cubed over something that begins with x, when x gets bigger, this x cubed gets bigger than anything else. And this x on the bottom eventually gets bigger than the -2. It starts to behave, in other words, when x is huge, it starts to behave as if the x cubed and the x were the only things that mattered. And when this thing starts to... Now, if the x cubed and the x were the only things that mattered, what would this fraction reduce to?
3 over 1. Maybe 3.
What's x squared? Thank you.
Oh, x squared. Oh,
Okay.
Sorry.
So the bigger this gets, the bigger x gets, the more this starts to behave as if it were an x squared. And that will happen all the time. If you divide an x cubed by an x and they're both polynomials, this all goes out the window if I put a negative or fractional exponent in. But as long as they're both polynomials and you divide anything x cubed by anything x, the answer is going to start with an x squared.
And it's x squared because x times x squared is x cubed.
Yes, and then those would cancel.
Yeah.
Okay. I was hoping to do one more of these first, but yeah, some of you might feel ready. Let me see.
I'm ready.
I'm ready.
You guys feel ready?
Yeah.
It's not that hard.
No, it's not, but it's going to be, again, how many opportunities do you have to...
Not that many if you actually do it right.
Here's hoping. Yes. Okay, look for trick questions on this, though, because remember, this only works if you're dividing by x plus or minus something, coefficient is 1, and remember to switch the sign on the number when you do it. And really, you want to get it this fast, because I'm going to give you some problems where You're going to be making some guesses, and if you're terrible at guessing, you'll have to do this like 5 times in a row on a test. So practice for accuracy and speed. Yes? Yes. The homework is...
Oh, can I shut it off?
let's get this on video. Let's see if I can avoid erasing it tonight. Page 356,
Yeah, you might want to be careful.
27 to 37 odd. I'm going to check to see if your homework's in the back of your book.
It actually was. It was my fault because I thought you said 356 and for some reason I got 369. Wait,
I'm
hold on.
fascinated, really. Okay, now, okay, go ahead and kill it, Eliza, and